Okay, so let's start. So like I said, what we're going to do today is very important. Very, very, very important. So I want you to pay attention to what we're going to do. So this is the paper we're going to revise. That is the last year, 2022 paper. But I'll focus more on section B. If you are lucky, I might make a video for section A if I'm going to have time. But for section B, a lot of questions I believe they are coming on Wednesday. So we can start. So the first question is you have first to read the instructions. Reading instructions is very, very important. You get my point, eh? Reading instructions is very, very important. You choose how many questions in physics? Hmm? How many questions do we choose? We leave how many questions? Hmm? Okay. You are going to read the instructions.
Three.
You leave three. Are you sure?
Yeah. Oh, there are seven, sir. So when you choose four,
No.
you left two.
There are seven. It's okay, there are six. Section B, because question one is for section A. Okay, let's do that one. So the first question is saying boxers in the 19th century used their bare feet. In wooden boxing, fighters wear padded gloves. How do gloves protect the brain of the boxer from injury? So here is a simple principle which you have to understand. The principle which you are going to use here is the impulse. Okay? What do I mean when I say impulse? According to impulse theorem, we know that impulse is equal to the force times time. If I want to find the time, I will divide both sides by t. Or sorry, if I want to find the force, I'll cancel this. I'll say force, my average force will be equal to the impulse divided by time. What does it mean? If the time increases, we expect the force to decrease. If the time decreases, we expect the force to increase. Our explanation is going to be based on this relationship. Okay? So what we should know is wearing padded gloves is going to increase time. Okay? So wearing padded gloves will increase time. We increase time. So now if we increase time, we expect our force to decrease. If the force decreases, we don't expect the injury to be there, even if they punch you. Have you seen the principle which is there? The force and the time. That is the relationship which we are going to talk about. Okay? So, if we reduce the time, the moment we increase the time, we expect the force to do what? The moment we reduce the time, we expect the force to increase. We increase the time, we expect the force to decrease. Now, wearing padded gloves is going to decrease, is going to increase the time. The moment we increase time, we expect to have less force. Okay? So how can you put it? So you say, according to the impulse theorem, the padded gloves increases the time. Okay? So once you increase the time, we expect to have more force, meaning they are going to be more. Sorry, Once we increase the time, we expect force to be less. The force is going to decrease. Okay? If the force decreases, we don't expect to have more impact when they punch you. So let me write this in case this question comes. So you say, according to impulse theorem, the force and time are inverse proportion to each other. So if the inverse proportion to each other, then you say in padding gloves, so, or you can say padding gloves increases. Let me just put it like this. I'll just put dialect padding gloves increases the time it increases the time for the fist inside the gloves. Thereby reducing the force. If you want, you can give them the formula to say the force, the average force, will be equal to the impulse divided by the time. So the relationship will come from here. But you can make your own English as long as you understand it from here. The moment we reduce the time, the moment the time increases, because padded glove is going to increase the time. The moment you increase the time, we expect to have less force. So less force, less impact. That's the only principle which is there. It's making sense, right? It's making sense? Yes, it is. Just take a screenshot if you are writing, because I'm about to erase this. Okay, so now let's go to B. Question B is saying a 75 kg ice scatter moving at 10 meters per second crashes into a stationary scatter of equal masses. After the collision, the two scatters move as a unit at 5 meters per second. Suppose the average force a scatter can experience without breaking the bond is 4,500 Newton. If the impact time is 0.00 seconds, does the bond break? Show your working to support your answer. Now here, let's assume that this is a ice scatter. This is just a scatter. This is moving. This is not moving. It is at rest. The velocity for this guy we have been given initially, which is 10 meters per second. The velocity for this one, since it was at stationary, is going to be 0. After collision, they are saying that these two guys were moving together as a unit. They are moving with a velocity of 5 meters per second. The mass is going to be cancelled out because the mass is the same. Okay? Now, the issue is this. The question is, this is just a scatter. This is an ice scatter. This is just a scatter. This is an ice scatter. The question is, suppose the average force a scatter can experience without breaking the bone is this. We're talking about the guy, the second guy, this one. Okay? So, the guy which was moving is going to bump into the scatter, which was stationary at rest. Now, this is going to have impact. The force that this guy is going to bump into the next guy is the one we are trying to find. Okay, so we are interested in the second part after collision, because that is the part where the second scatter was moving. Okay, so we are no longer interested in this 10, because this 10 is just for this guy, and we are not interested in that one. We are only interested in the second one. Is it going to break or not? Therefore, we are going to use now this velocity. So here, using the data, if we can see the data which we have been given, we have the mass as 75 kgs. What else? We have the velocity as 5 meters per second. What else do we have? We have the time to be equal to 0.100 seconds. We don't have the force. The question is asking about the force. Using this information, if we find the force, then we find that the force is greater than 4,500, then the bone will break. If the force is less than 4,500, the bone will not break. Is that okay? Is that okay?
Yes.
We continue. We continue.
Yes.
Okay, so now we know that we have the mass and velocity, that is definite momentum. Time and force, it is an impulse. We know that impulse is equal to the change in momentum. So impulse is given by the force times time. Then momentum is given by the mass times the change in velocity. So the force, I'll divide both sides by time, even here by time. So the force will be equal to the m times the velocity times t. Plugging in the values, the mass is 75, the velocity is 5, divided by 0.100. What will be our force? So we have 75 times 5 divided by 0.100. So I'm getting a 3,750 newtons. We can clearly see that 4,000, this is less than, it is less than this. So the conclusion is that the bone does not break. Since this force is less than the force we have been given. Okay. We go to the next one. Question part C. The speed of the nerve impulse in a human body is about 100 meters per second. If you accidentally stab your toe in the dark, estimate the time it takes the nerve impulse to travel to your brain. Now, this is where we lost some people last year, because this question, it came again in 20. Now I'll be telling you, part A, it came in 2021 and 2022 final exam. It can also come after tomorrow. Then part B, it also came in 2021 and 2022 exam, and part B is also coming in 2022 2023, so you have to know it. Then part C, it also came in 2021 and 2022. It might also come, who knows. Now, where we roast our brothers and sisters, both last year and 2022 or 2021, is here. Estimate the time it takes the nerve impulse to travel to your brain. We are talking about your brain, okay? We are just estimating. So, to estimate the time, we know that speed is equal to distance over time. Estimate the time. We're trying to find the time, so I'll make time as a subject of formula. Crossing multiply, I'll find that t will be equal to d over speed. Now, let's estimate the distance. We're talking about your brain. So we're going to estimate the distance from, we're going to say that maybe your distance is about, if you want, you can get 1.6, it's okay, even 1.5. Okay, so 1.5, or if you want, you can get 1.6, it's okay, no one is going to penalize you. So if I get 1.6, the speed is 100. What will be our time? So I have 1.6 divided by 100. I'm getting 0.016 seconds. Now 1.06, that is going to be the time it's going to take for a nerve to reach to travel to your brain. That is the answer. Then part 2 is saying assume what would happen if the speed of the nerve impulse was much lower, let's say 1 meter per second. So you still find the time. The speed is the same, the distance, sorry. Then the time now, or the speed now, have been told that it is 1. So time will be 1.6 seconds. What will be your conclusion? What would happen if the speed is 1 meters per second? We have found that the time is 1.6. What will happen? Cindy, are you here?
Yes, I'm here.
Give us the answer.
Okay, so from the answer I got from that paper you sent with solutions, it says it can be.
Not from the answer you got. From what you have seen here, we have found that the time is 1. When the speed was 1000, was 100, the time was 0.016 seconds.
It will take it longer to reach the brain.
Exactly. So stop now. So now stop saying no. According to the answers I got, no. According to what you have seen here.
No, I wanted to refer to that, then give my explanation.
No. That
Based off of that.
you can't give that as a reference. What if the answer is wrong there?
No, it can't be wrong. I researched. That's why I was using it as a reference.
Okay. So it will take time for the impulse to reach the brain. As we can see, the time now is 1.6 seconds. That's all. We go to D, which is vector. So we have our question for vector. I think this question I can solve it from here, on top here. Okay, cool. While exploring a cave, a person starts at the entrance and move the following successive distance. She goes 75 meters north, 100 meters east, 150 meters at an angle of 30 degrees north of west, and 300 meters south. Find the resultant displacement from the cave entrance. Listen, here they're just asking you to find the resultant displacement. But a vector can't stand alone without the angle, without the direction. You never see a question asking you to find both the resultant and the direction. But you yourself, you should know that since this is a vector, once I find the magnitude, I need also to find the direction. Because a vector is a physical quantity which has got both magnitude and direction. Okay? Meaning, once you we are done with this one now. Let's go to the next one. Now we're on question 3. So question 3 is saying explain how a body moving at a constant speed can be accelerated. Initially, if we are talking about linear motion, okay? If you're talking about linear motion, then the object is moving at a constant speed. The acceleration is 0. You know that, right? So the object can only be accelerated at a constant speed if an object is moving around the circle in a circular manner. Why? Because we always have centripetal acceleration. Okay? So, even if it is changing the direction, so you can say an object can be accelerated an object can be accelerated an object moving is you start with an object moving at a constant speed. Can you write this? An object moving at a constant speed can be accelerated if the object is moving in a circular manner. So when an object is moving in a circular manner, we have two acceleration. So if it is moving at a constant speed, the tangential acceleration, yes, is going to be 0, but the linear acceleration will be there. Sorry, the centripetal acceleration will be there. What I mean is this: when this object is moving, let's say this is tangential acceleration, then the centripetal acceleration is there. This acceleration is just constant, doesn't change. Sorry, the velocity. So it is moving with a constant speed, but we expect to have the linear acceleration at the same time, or tangential acceleration at the same time we have centripetal acceleration. The centripetal acceleration, the object will keep on moving, it will be accelerated because it is moving in a circular manner. Now there is centripetal acceleration which will make this object to continue moving. So this object will just keep on moving in that direction. Okay? So you can say an object moving with a constant speed can be accelerated if an object is moving in a circular manner. Then you explain about the tangential and the centripetal acceleration if you want in that way. But it's just two marks. They just want you to know how can it be accelerated if it is moving with a constant speed. It can be accelerated if it's moving only in a circular manner. Okay? So without wasting our time, that is it for that part. Now let's go to part B. Part B is saying an airplane carrying out a parcel releases a parcel while traveling a steady speed of 90 meters per second at an altitude of 200 meters. Calculate part A, the time between the parcel leaving the airplane and it striking the ground. Part B, horizontal distance traveled by the parcel before hitting the ground. Okay, here just understand this, then come up with a free body diagram. We have been told that the altitude is 200 meters. Here is our airplane. Is traveling, this is the ground, is traveling while dropping the parcel. So now that parcel will fall in form of a projectile. This guy is moving in this direction, but the parcel will come like this. Will come like that. So it will come as a projectile. Now we have been told that the speed, listen here. An airplane carrying out a parcel drop releases a parcel while traveling a steady speed of 90 meters per second. What does it mean? The parcel, when the parcel was dropping, is going to have two motion. Okay, since it's going to drop like this, we expect to have the motion in x-axis and the motion in y-axis. When the parcel was being dropped from the top here, in y-axis the velocity there, the final velocity is 0. But this velocity which have been given is the velocity for x-axis, which is 90 meters per second. Have you seen that? When the parcel was being dropped from the top of the altitude, the velocity in y direction, initially it was 0. But we have the velocity in x direction which we have been given here, which is 90 meters per second. The first question is saying, calculate the time between the parcel leaving the airplane and it striking the ground. Now, when the parcel was coming now, we are using the y-axis. So we'll say distance is equal to the Vy times t plus half at squared. The Vy, the velocity in y direction is 0. I expect this to be cancelled. So I'll say h, d is the same as h, half. Now a in this case is g because it was falling under the influence of gravity. Okay, I want to find t. If I want, I can just plug in the values direct without wasting much of our time. Half 9.8 t squared. A 200, half of 9.8 is 4.9 t squared. We divide both sides by t square. We divide both sides by 4.9. So I'll do it from here. We divide both sides by 4.9. 4.9 t squared, we expect it to be so I get the square root both sides. T will be the square root of 200 divided by 4.9. So t will be equal to, I'll say a 200 divided by 4.9. If you want, you can just do it direct. That's when you can square root. Then I square root it. I'm getting 6.39 seconds. Are we okay?
So I have a question.
Please ask.
So every time we're told to find the time, is this the formula we're supposed to use?
No, it just depends with the type of trajectory you are dealing with.
Okay.
Do you know that this is the first trajectory? Hmm?
No.
Uh, okay, so I'm going to send you another video which I explained because it will take time. I don't want us to take much of time explaining projectile motion because one question is coming under projectile motion. There are not two questions. I'm going to send you a video. You should just remind me. I'm going to send you a video. That video is very powerful. Okay? I'm going to send you a video where I explained everything about projectile motion. Then I also solved some past papers under projectile motion. I think that video is going to help you. But for now, I want you to understand this question. Okay? Now, how do we find the another question is calculate the horizontal distance traveled by the parcel before hitting the ground. The horizontal distance they're talking about is the range, this distance here. Range. So range is Vx times t. The velocity in x direction we know is 90. The time we have found already. So what will be our horizontal distance? 90 times 6.39. I'm getting a 575.1 meters. I'm done with that question. Unless you have questions. Okay. We move. A car towing a caravan travels along a steady speed of 20 meters per second. If the force exerted by the engine is 20 kilonewton, what is the power output of the engine? Now listen, here we have been given the what? The force in kilonewton, meaning that my power has to be in kilowatts. Okay? If the force was in newton, my power, I would have put it just in watts. But anyway, that doesn't matter. So power is work divided by time. But I don't have work, I don't have work, I don't have time. I have to modify this formula. Work is equal to force times distance. Let's replace work with force times distance over time. I don't have the force, or I have the force, I don't have the distance, I don't have the time. Speed is equal to distance over time. So I can isolate this power to be the force, distance times divided by time. This is speed. So I can replace that with speed. I can say that power is force times speed is the same as the velocity. This is the formula which you have to know. It's also important. So power is equal to I'll do times 1000 to convert to convert to convert what? To convert kilonewtons to newtons. So I'll have a 2000 newtons. So I'll have a 2000 newton times a 20. So power will be a 40,000 watts. You can leave it there if you want. Again, if you want, you can divide it by 1000 to change this one from watts to kilowatts, so it will be 40 kilowatts. Done. Any question? Then I want to explain this question, part D. I need space. I really need space for this question. Let me go here. Now, it's Young's modulus. Let me just explain about Young's modulus. Young's modulus is given by stress over strain. What is stress? Stress is given by the force divided by area. Is the ratio of the force and area. Strain is the ratio of the change in length times length original. So the SI unit for stress is Newton per meter squared. Strain has got no units because meters and meters will cancel. That is what we should know. Okay, I can modify this formula and say Young's modulus, stress is given by force divided by area. Then I have stress or strain, the change in L divided by L initial. I'm trying to modify this. So Young's modulus will be equal to the force, this is the same as the force divided by area divided by the change in L initial, like that. Again, Young's modulus, I can change this is the same as force over area times the L initial divided by change in L. If we do multiplication there, we'll be able to have this. The force times this area times change in L. So this is the formula for Young's modulus. Is that okay? Again, if you want, you can just find strain there, stress there, then plug in direct. So using this formula, I've just derived this formula. Now I can go back here and solve this. So we are saying Young's modulus is given by the force times L initial divided by area times change in L. We plug in the values. Let's first gather our data. What do we know? A 15 centimeter long tendon found to be stretched 3.7 millimeters. Stretched, when you see stretched, that is the change in L. Okay, so our change in L is 3.7 millimeters. We have to convert this from millimeters to meters. Changing from millimeters to millimeters is to divide it by 1,000. Dividing it by 1,000 is the same as just saying 3.7 times 10 raised to the power negative 3. Now this is now in meters. What of our L initial? Our L initial, we have been told, is 15 centimeters. Changing centimeters to meters divided by 100, I'll get 0.15. What else do we need to know? The force, we have been told, is 13.4 newtons. What else? The area. The tendon is like this, so it has got the radius. The area is given by pi r squared. So we have been given the diameter. To find the radius, in this case, the radius will be 8.5 divided by 2 to find the radius. So 8.5 divided by 2, it is 4.25 millimeters. Converting this from millimeters to meters, just divide by 1,000 or times 10 to the power negative 3. So my radius now will be 4.25 times 10 to the power negative 3 meters. If I want, I can find area in advance. That is if I want. Okay, so let's now find area. So pi times 4.25 times 10 to the power negative 3. Now we have to square this. What will be our area? 4.25 times 10, which is exponent 3. I square it. times pi. I'm getting 5.6775 times 10 to the power negative 5, meaning this is now meters squared. So we have found now the area. Let's go back to our formula. But first, do you have questions? Do you guys have questions? Hello? Do you have questions? Okay, no. So now, I'll say Young's modulus. The force is 13.4. Change in L is 0.15. Divided by the area is 5.675 times 10 raised to the power 5 times. I can put this in brackets if I want. The change in L is 3.7 times 10 to the power negative 3. So our Young's modulus will be 13.4 times 0.15. I divide this, I'll now put that in brackets. I'll say open brackets 5.675 times 10 to the power negative 5, which is exponent negative 5, then times 3.7 exponent negative 3. So the answer I'm getting is this. 931,535. I don't know how to do what's this. Let me just write it. So this is 931,539,469 newtons per meter squared. Now, it's good for us just putting this in scientific notation, because how is it going to be in scientific? One, two, three, four, five, six, seven, 8. Isn't it supposed to be to the power 6? I remember I solved this last year because it came even in 2021 final exam. It came. Okay, those having calculators, please can you punch for me? This was to the power 3, right? Not 5. No, I mean this one was to the power negative 5. Okay, let me redo it. 13.4 times, but it's better for you just finding stress and strain separately. So let me do this. If you don't want confusions, I can advise you to do this. You just say stress is force, so the force is 13.4. Then the area, you know that the area is pi r squared. So the stress will be equal to 13.4. So we have pi times the r is this one, which is 4.25 times 10 to the power negative 3. Now this has to be squared. So I'll say 13.4 divided by open brackets pi times 4.25 exponent negative 3. Now we square that. Okay, so I'm getting my stress. I'll put it here. I'm getting my stress to be 2.36 1 times 10 to the power, let me just get rid of this, times 10 to the power to the power 5. I'm getting this as my stress. Let's go ahead and find the strain. So strain, we have change in L over L initial. So change in L, we are saying it is 3.7 times 10 to the power negative 3. L initial is 0.15. So what will be our strain? 3.7 times 10 to the power negative 3. I'm getting what? Divide this by 0.15. Okay, so I'm getting can you confirm? I'm getting 2.466. So I can say 7 there times 10 to the power negative 2. Confirm. So stress is Newton per meter squared. Then this is just the unit race. It doesn't have units. That is strain. Now we can go back and say, you guys were no longer participating now. And you make me tired because you're not participating. I'm doing everything around. She is not good. Cindy.
Yes, sir. I'm listening. It's just that I'm also getting my son ready for school. So I'm unable to calculate on my side.
Okay. So using this formula now to say stress over strain, our stress is 2.361 times 10 to the power 5. I divide this by 2.4667 times 10 to the power negative 2. So Young's modulus will be equal to 2.361 times 10 to the power 5 divided by 2.4667 exponent negative 2. Yeah, so now, so it's, I think I'll advise you to find stress and strain separately, then you come now plug in the values. That's when you can find accurate answer there and then, because sometimes if you just drive the formula you might make a mistake. So 9.614 times 10 to the power 6 Newton per meter squared. Now the SI unit for Young's modulus and stress, they are the same. Okay, so that is the answer for question 5, unless you have questions. Are we tired? If you are tired, we can stop from here. Are we tired?
No, let's move on.
Okay, let's solve question 4 and then we see what we can do, because we have to finish this before you write your final exam. And the problem with me is that I don't teach one day before exam. You can mute your mic. I don't teach one day before exam. That's the problem. So let's solve this. Question 4. Question 4 is saying the force of gravity on 2 kg rock is twice as larger as that of 1 kg rock. Why then doesn't the heavier rock fall faster? Now this question is on a free fall motion. So on free fall motion, what you need to know, guys, is that if I've got an object of 2 kgs, I'm just starting now, and then you want to ask Arinani.
It was a mistake.
If I have got a 2 kg block, I also have another block of 30 kgs. This is the ground. You are trying to throw this with the same velocity. This has got the mass of 2, this has got the mass of 2, but they are going to reach on the ground at the same time. If this is going to reach on the ground at exactly 2 seconds later, same as this one 2 seconds later. Why is that so? Free fall does not depend on mass. When an object is moving on free fall, it does not depend on mass. Based on this explanation, how can we answer this question? The force of gravity on 2 kg rock is twice as larger as that of 1 kg rock. Why then doesn't the heavier rock fall faster? So we have got this 2 kg and 1 kg, but they discovered that when you throw them, they are going to reach on the ground at the same time. Why then don't you think that this is going to fall faster than the 1 kg rock? What would be your explanation? Mhm.
Sir, I think because the gravity is the same.
Yeah, the gravity is the same. So one, you say, because it's going to experience the same acceleration due to gravity. They are going both to be moving with 9.8 meters per second squared, regardless of the mass. At the same time, you can say that since the object was moving, there are two here. You can talk about the acceleration due to gravity, or you can say free fall does not depend on mass. Okay, it does not depend on mass, so even if the object is heavier, it's still they are going to be moving the same acceleration due to gravity. But the best explanation here is that they they are going to be moving with the both what 9.8 meters per second squared. So they're experiencing the same acceleration of due to gravity, or you can say they're both experiencing the same force of gravity. The good part with this paper is that as we are solving this paper, it's the same as we are solving for 2021, because 90% of the questions which came last year, they came in 2021, and 70%, or let me just say 80%, at least 80% of what we are solving today, they are likely to come. Okay, they are likely to come. So let's just understand the principles here. Part B. Police investigator examine the scene of an accident involving two cars measuring 72 meters long, skidded mark of one of the cars, which nearly came to a stop before colliding. The coefficient of kinetic friction between the rubber and the pavement is about 0.8. Estimate the initial speed of the car assuming the level load. Okay, so now here what we need to understand, guys, is simple and straightforward. There are two methods which I'm going to show you. So let's assume that this is the level load. The distance we've been told that is 72 meters. You can ask,
Sir, the board is not showing.
You are sure the board is not
The
showing?
board is not showing that. I'm showing here.
Are you sure the board is not showing? No, it's your network. That's not true. Try to leave the meeting and then rejoin it. So the police, okay, we since we have already managed to read the question, so we are trying to find the initial speed. As the car was moving, let's say from this point going in this direction, the speed at which it was moving with, we don't know. It's the one we are trying to find. When the accident happened, this is going to reach there, so we expect our final velocity to be 0. Is that okay? We have been given the mu value to be 0.8. Therefore we can find the what? We can find the acceleration if we want. I'm going to show you two methods. The first one is I'm going to use Newton's laws of motion. The third one, or the second one, I'm going to use work, energy, and power. So let me first start with Newton's laws of motion. So to find the acceleration, I'm going to say the summation of all the forces. In this case, the only force which was present at that point is the friction force. It's the one which was opposing the motion. Now, since friction force always opposes motion, this object was moving in this direction, friction will be acting in that direction. Therefore, it will be negative friction force. Okay? It's negative because it's moving in opposite direction. We don't have any other force apart from friction force. So, since it was opposing motion, that's the reason why I've included negative. Again, I've included negative because I'm trying to find the acceleration, and my acceleration has to be negative because it was decelerating. It's making sense, right? It was decelerating. I expect my acceleration to be negative. At the same time, since friction was opposing the motion, that friction force is going to be negative. Jesus Christ. It's telling me that I've used 90% of my data. Jesus. Okay. So now, according to Newton's second law, mass is equal to force is equal to mass times acceleration. So this is going to be mu times the normal force. So ma is equal to negative mu. The normal force is mg. Not so. In this case, the normal force will be equal to mg. We have not been given the mass. Let's cancel the mass. So A will be equal to negative mu g. A will be equal to negative 0.8 times 9.8. So what will be the answer? Guys, the problem is that you are not helping me to find the answers here. So the impact here will be, I'll get tired easily. You get my point? Huh?
7.84.
7.84 meters per second. So it's negative, right? Because of that negative. So it was decelerating, so our acceleration is negative 7.84 meters per second squared. I'm done finding acceleration. So to find, I have now initial acceleration distance. Which formula from Newton's or from linear motion, which formula can I use to find the initial velocity? I can use this v final squared v initial squared plus 2ad. Shifting this to the other side, I'll say v final squared minus v initial squared. No, we are trying to find the sorry, we are finding what? I'm supposed to shift. Okay, let's just plug in the values direct. This is 0, this is we don't know. 2, acceleration is negative 7.8 4, the distance is 72. So we have 0 is equal to v squared. This will be minus, I have 2 times 772 times 7.8, 4. Confirm with me, I'm getting 1128.96. Shifting this to the other side, we can see that v initial squared will be equal to just this. Get the square root, here square root, so I'll get the positive one. V initial will be the square root of this is 33.6 meters per second. That's the answer. Those having calculators, have you found the same answer? Confirm, please.
Yes. Yes.
I'm going to show you another method on how to go about this question. Now that method will come from work energy theorem. Now get rid of everything. I'll say work net is equal to the change in kinetic energy. Now the only force which is present at that point is the friction force. So I'll just say the work done by the friction is equal to the change in kinetic energy. If you have got only friction present at that point, you just say the work done by the friction is equal to the change in kinetic energy. Because the work net, since I only have friction force, is going to be the same one. Then I'll say friction work done by the friction force is going to be the force times the distance. But now this force, since it is the friction force, is going to be negative Fr times d. This has to be equal to the final kinetic energy minus the initial kinetic energy. So I'll say negative, this is going to be mu times the normal force times d is equal to, since the final is 0, I'll cancel that. I'll just remain with negative half mv initial squared. I can cancel the negative, or before I cancel the negative, I'll just do this. Normal force is mg times d is equal to negative half mv squared. At this point, I can cancel the negative, I can cancel the m. Therefore, I'll remain with negative mu gd is equal to a half v squared. Since I want to find v, I can do times 2 everywhere to get rid of half. So it will be now, negative now is no longer there, it has disappeared because we have cancelled the negative. So it will be 2 mu g d is equal to v squared. So we get the square root both sides. V will be equal to the root of 2 mu gd. So v will be equal to 2 times the mu is 0.8 times 9.8 times 72. Now in the square root. So I'll say, those having calculators, please help me. What is inside there? It will be, then I get the square root. I'm getting exactly 33.6 meters per second. Which one is better for you?
I think the work theorem makes sense.
The work theorem makes sense. Okay. So we are done with that one. Now let's go ahead and find part C. Part C is coming from elevators. So I have to explain something on elevators. If this is an elevator, an object is here. No, I'll just say the person. This is the scale, this is the person standing on the scale. Let me redraw it. You know what an elevator is, right? Hmm? You know what an elevator is?
Yes.
And you know what's happening there? We're not talking about elevators. Or do you know anything on elevators? Or maybe I need to explain everything. Hmm? I'm not talking alone.
Sorry, can you explain?
I just explained. Okay, let me explain about elevators. So under elevators, what you need to know. Uh, okay, let me first draw a free body diagram. I'll draw it from here. I'm assuming this to be an elevator. Then this is the scale. Okay, so this is the person. Okay, now what we have to know, guys, is this. So now this is an elevator. So there is a guy. Now if this person is moving, going up, so there are two scenarios. Okay, there are two scenarios. If this person is moving, um, going up, we expect to have two things. So now when an object is going up and when an object is coming down, okay, so the most important thing which we have to consider is the acceleration. So is the acceleration going to be negative when going up or negative when going down? I believe you have been watching my videos. And this one, guys, don't pretend as if you don't know these things. Hmm? Jesus. Are you telling me that you don't know anything about elevators? No, then this is not fair now. Then I'll not explain because there's no way. If you have been watching my videos, I explained about elevators. Are you telling me that you don't know anything about elevators? When an object is going up, is the acceleration negative or positive?
The acceleration must be positive when it goes up and negative as it comes down.
Uh-huh. Yes, so when it's going up, the acceleration is positive, negative when it's coming down. After knowing this, you are not going to have any challenge on how to solve elevators question. Now, you do this. There is a force that is exerting by this person, which is the normal force as usual. The weight force, sorry. Then the normal force is perpendicular to that, which is like that. Okay? Now, we are going to say the summation of all the forces in y direction. The normal force is pointing upward, positive, minus the weight force, like that. Okay? So now what we are going to do is this is replaced by mass times acceleration. Fn, this is going to be minus mg because weight force is just mg. I'm going to shift this. In most cases, they are going to ask you to find the normal force. I'm going to shift mg to the other side, meaning that my Fn will be equal to ma plus mg. Okay, I can factor out m. It will be Fn will be equal to m open brackets a plus g. This is the general formula for elevator. You can use this formula to find now anything. Now, the formula is simple, but the only thing now remaining is you understanding the question. Was this person going up or down? If the person was going down, the acceleration they are going to give you is a positive always, but you have to think yourself. Okay? Now, this they are saying you are rushing a 80 kg patient lying on the scaled bed to the 5th floor. So it was going up, the acceleration is positive. So we're going to get this 4 meters per second as positive. If it was coming down, we would have gotten it as a negative. So we'll go there and find the normal force now. The question is, what will the scale lead? Now in kgs. We need just to find the normal force. After finding the normal force, then we convert this now finding the mass. So we'll say the mass is 80, acceleration is 4, then g is 9.8. We expect our normal force to be 80 open brackets 4 plus 9.8. So I'm getting my answer to be 1104. That is Newton. But the question is, most of the time they're going to ask you, what will the scale lead? They want you to find the normal force. The scale will always lead the normal force. That's the principle of elevators. But in this case, we've been asked to find the mass now. So you say the normal force is equal to mg. You use this formula now to convert the normal force to what? To kgs. So you say you divide both sides by g, even here by g. So mass will be equal to the normal force, which we have found is 1104 divided by 9.8. So we expect our mass to be what? Our mass to be 112. Not so. Yes?
Is the force not 110.4?
Oh, it's 110.4?
It's 110.4, not 1104.
Okay, let me do it. We are saying 4 plus 9.8 times 80. I'm getting 1104.
Okay, sir, thank you.
What are you getting yourself?
I used 8, not 8.
Why did you use 8?
I just made a mistake.
Okay. So you divide this by 9.8. So you say 110.4 divided by 9.8. I'm getting 112.6. What are you getting?
The same.
Okay, someone can also divide it. These answers, they most of the time they're going to put it as a range. Someone can also use 10, rounding off, because G can also be 10. You can divide this by 10. Then someone can also find 110.4 kgs. They'll still mark it correct. Is that okay? Let's go to the last question. So the last question is under units. These ones you are going to be doing it even in second year, especially those who are doing biomed. It's part of the labs. The question D. So delivering medication in another critical function that you will perform many times on every shift, and mistakes in dosage can have very serious consequences. Dosage calculation ensure patient receive the correct amount of each medication. A medical doctor orders 300 milligram of brufen to be taken by a 6 kg infant every 4 hours. The table shows the reference. This is now the reference range. The table shows 75 to 150 milligrams per kg per day max. Is the physician order within the normal range? Now, what they are trying to tell us here now is this. Before I explain, do you have idea on how to solve this question? Calculate the dosage, ensure the patient receives the correct. A medical doctor orders 300 milligrams of brufen to be taken by a 6 kg infant every 4 hours. So now the question is the physician order within the normal range? The range is 75 to 150. So if we do these calculations using this data which have been given, then we should know that the answer, if the answer will fall within the range of 75 to 150, then it was in normal range. But if it's going to be out of that range, then it was out of the range. Is that okay? Hmm? Now I'm asking you, do we have anyone having ideas before I explain? Solving this is not hard. Let me now tell you. You just check the normal range. The normal range you have been given milligrams per kg per day. Meaning everything which you have to change it in milligrams. If this one is already in milligrams, we'll leave it the way it is. Kg, we already have kgs, we'll leave it the way it is. But here there is per day. We have to convert this by what? To days. You get my point, eh? So there is nothing complicated here. This question was very simple because you just say a 300, you put it on top here. You divide it by, this one is kg per day. So this is together now. So you say 6 kgs, this is now milligrams, times 4. But this 4 is 4 hours. Now we have to convert these 4 hours to days. So I'll say in 24 hours, if you want you can convert in advance. I'll say times in 24 hours, there's 1 day. Why am I doing this? I'm trying to cancel hour, and hour. Now I can do the math here. I can say a 300 times 24, then I'll divide this by 6 times 4 is 24, right? Divided by 24, I'll get a 300 flat. So the answer is 300 milligrams per kg per day. What will be your conclusion? What will be your conclusion? Come on, guys.
The physician's prescription is out of the normal range. It's not within the normal range.
Exactly. Now,
But
ask me, are you having challenges on how to find this? Now, finding this is not difficult because they always give you the range. Once they give you the range, you just follow the range, because the range here is saying that the answer should be in milligrams per kg per day. So when we say per kg per day, what it means there is that we have got milligrams, down here we have got kgs and day. So the one which we have been given kg and day, since we have been given this 4 hours, we have to convert this one in days. After converting that one in days, just multiply it with the mass, then put the milligrams on top, divided by this. That is the answer. So you always follow the range. It's not something difficult. It's just direct. Is that okay? So question 5. A person has a reasonable chance of surviving a car crash if the deceleration is no more than 30 Gs. 30 Gs is the same as 30 times G, which is 9.8. Calculate the force of a 70 kg person undergoing this acceleration. What distance is traveled if the... So there are two questions here. What distance is traveled if the person is brought to rest at a rate from 100 kilometers per hour? Let's find the force. Mass times acceleration. So the acceleration is 30 times g. 30 times 9.8. So we have 30 times 9.8, which is 294. That is my acceleration. 30 G's is acceleration. 30 times G, that is your acceleration. So that is 30 times G, that is acceleration. Now they want us to find the force. The mass is 17. The acceleration is 294. Therefore, this is going to give me a 20,580 newtons. That is the force. Part 2 is saying what distance is traveled if the person is brought to rest at a rate from 80 kilometers per hour. They want us to find the distance now. Since we have the acceleration, we have been given the the initial. So the final velocity we expect to be what? If you have understood this question, if it was brought to rest, meaning the final is going to be 0, the initial is the one we have been given. But let's convert this from kilometers per hour to meters per second. I'll say 100 kilometers divided by 1 hour times, in 1 kg there's 1000 kilometers. This is wrong. What I'm doing is totally wrong. Now using dimension analysis, I can say that in 1 kg there is 100, there is 1000 meters, sorry. Then in 1 hour there is 3600 seconds. Who doesn't know this? Hmm? Who doesn't know what I'm doing?
I think you're supposed to write 1 kilometer.
I'm putting 1 kg, 1 kilometers, yes. Supposed to be 1 kilometer. Supposed to write, okay, let me redo it. The force, we are saying the force, let me just put it here. But we no longer need the force anyway. I'm converting 100 kilometers in 1 hour. So in 1 kilometer, we have 1000 meters. In 1 hour, we have 60 minutes. Again, in one minute, we have 60 seconds. You can also use this. You start now cancelling out. Kilometers and kilometers will cancel. Hour and hour will cancel. Minutes and minutes will cancel. Therefore, we'll have 100 times 1000 divided by 60 times 60 is 3600. So I'm getting 8.7.77. So I can just 78. Anyone who is having challenges on how to convert this, please be open. Be open. Be open. Come on, guys. Okay, you know, which is good. Now what I'm going to do is I don't need to erase the acceleration though. Do you have people who are writing? What did we say about acceleration? I said is what? 30 times 9.8. 294, eh?
Yes, 294.
We don't have time. Which formula are we going to use? V final squared V initial squared plus 2AD. So what I'm going to do is the final is 0. The initial is 27.78 squared plus 2, acceleration is 294. When it was brought to rest, what will be the acceleration? It will be decelerating, not so? So we expect our acceleration to be negative because when something is brought to rest, it is decelerating. Now you change the acceleration from positive to negative. So I'll put negative here. Time the distance is the one we're trying to find. I'll shift this to the other side. So I'll have negative 27.78 squared is equal to 294 times 2. I'll get negative 588d. Divide both sides by 588, negative 588. So my d will be equal to negative and negative will go. 27.78 squared divided 27.78 squared divided by 588. What are you getting? I'm getting 1.32. Confirm?
1.31.
Okay, so that's the answer for that one. Now we can go to part B. So part B is a weightlifter lifts a 350. This one also came in 2021. lifts a 350 Newton set of weights from ground level to a position over his head, a vertical distance of 2 meters. How much work does the weightlifter do, assuming he moves the weights at a constant speed? Now, this question, I remember in 2021, a lot of students got it wrong because they thought maybe the work done is 0, but they didn't consider this statement. Vertical. So this is the person. So the distance, the vertical distance is 2 meters. Then the force is also going in the same direction, which is 350 newtons. Now, in a case where they say horizontal distance is 2, that's when the work done can be 0. But the vertical, meaning they are going in the same direction with the force. So you say the work done is equal to the F times D. Work is equal to the force is 350 times 2. So what is 350 times 2? 700 joules. Now, a lot of people got it wrong, like I said earlier. They found work done to be equal to 0 because they didn't consider this statement, vertical. Unless if it was horizontal, that's when the work done can be 0. We are done with that question. Any questions so far? No question. Okay, so if you have been watching my videos, I think you have come across this question, right? I solved this. But anyway, for the sake of revisions, we are solving again. The three vector A, B, and C are as shown. Find the magnitude and direction of vector D, which when added to these three vector will give the resultant, will give 0 resultant. What does it mean? If it's going to give 0 resultant, meaning that the R component, the Rx is 0, the Ry is 0. Because 0 cos anything is going to be 0. 0 sin anything is going to be 0. If you have missed that point, let me know. I explain again. We are saying that when you add A, B, C, the resultant will be 0. So the resultant is 0. So to find the x component of the resultant, we know that it's going to be x is going to be r cos theta, not so. But r is 0. So 0 cos anything, even if we don't know the angle, but 0 times anything is going to give us 0, not so. That's why the Rx is 0. Same applies to Ry. Ry is to be r sin theta. Since we don't, even if we don't know the theta, but we know the r is 0. 0 times anything, it will be 0. That's why I'm saying the Rx is 0, the Ry is 0. Have you understood now?
Yes.
Let's go ahead now and solve this. After knowing that the Rx is 0, the Ry is 0, now we can resolve each vector into x and y component. After that, then now we add them. So that we find vector D. Vector D is the one we don't know. If we add A, B, C, and D, the resultant has to be 0. So we are finding, so we are going to say AX will be equal to A cos theta. AX will be, my A in this case is 210. The angle, since it is going in this direction, the angle is 180. So my AX will be negative 210. Because cos 180 is negative 1. Not so. So my BY will be B sin theta. I know I'm fast because I know that at this stage you know it. Okay? So we have 210 sin 180 is going to give me 0. Because I don't have sine in x-axis. So I'll be putting these ones here. We have found that AX is negative 210. BX, let me just do this. Then BX is 0. Now I can get rid so that I can get rid of this so that I use that space to find now b. So for b, it will be bx. It will be bx will be equal to b cos theta. Bx will be equal to what? If the angle is in the second quadrant, since we're getting the angle from positive x-axis, I'll use the same 45. So the b is 180 cos 45. So bx will be 180 cos 45. I'm getting 127.78.28, sorry. Then my by will be equal to b sine theta. If you want, you can use a table. I know you have been watching my videos and you know what I'm talking about, the table components. You can use that. So my by will be equal to 180 sine 45. If the angle is 45, the answer you get for sine and cos will be the same. So I'll still get the same. Okay, I'll put them here. Bx to be 127.28, by to be 127.28. Let's go now to C. We are together there, right? We are together. So Cx will be C cos theta. Cx will be my C will be 110. The angle now, the angle we are going to use, we get the angle from this point all the way to this. So I'll say it's either I can say 270 plus 60 or 360 minus 60, which I'll still get 300. Is that okay? So we are using the angle from positive x-axis. I'm getting the angle from this point all the way to there until it touches the vector. I believe you know that by now. Cos 300. Cx will be 110 cos 300 is giving me 55. I want you to, yes?
Isn't it that considering the fact that the distance from like that small angle where the 60, the other angle will be 30. So I'm not supposed to use 350.
We're supposed to use what? Oh, sorry. I'm supposed to say, yeah, thank you. Okay, initially this one you can just do this. You know that from this point all the way to this is 270. And we're trying to reach at that point. So it's just 270 plus 60, which is 330, right?
Yes.
Now, in a case, I made a mistake. In a case where you have this 60 is here, that's when you can say 360 minus 60. You get my point, eh? If the 60 was here, that's when you can say 360 minus 60. So we're getting the angle from positive x-axis until it touches the vector. So we know that from this to that is 270, then we add that one, so 330. Thank you for that. So it's going to be 330 here. I'm supposed to put 330. So it's going to be 110 cos 330. I'm getting 95.26. Confirm. Then CY will be 110 sine 330. So 110 sine 330 will be equal to negative 55. Confirm.
Yes, sir.
Negative 55. Now I'll get rid of this. D we don't know, so D we only have dx, which we don't know, and also dy, which we don't know. But Rx we have 0, Ry we have 0. So we go ahead and say we add the x component alone. Rx will be ax plus bx plus cx plus dx. So Rx is 0. I'll put 0 here. Ax is what? Negative 210. Bx is 127. Cx is 95.226 plus dx. Dx we don't know. We are trying to find dx. Let's add those. So negative 210 plus 127 plus 95.26. I'm getting 12.26. Confirm. Confirm, please. What are you getting? So if I shift this to the other side, I'll have dx to be equal to negative 12.6 this. Confirm that.
So I'm getting negative 12.46.
You're getting negative 12 point what? 46. No, 46. We can't have 46 because we don't have any decimal apart from this. Apart from 26.
Oh yeah, made a mistake of saying.
As we are trying to confirm, let's go ahead and find now dy. Using Ry will be equal to ay plus by plus cy plus dy. But confirm this. I can make a mistake, yes, I know. Just confirm that one. If it's negative 12.26 using your calculators. Because once we make a mistake, if this question comes, you are going to make a mistake. Because as you are solving, you are going to be remembering negative 12.26. Okay. 0. Ay is what? 0. By is 127.28. No, 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 no. We had bx as 127.28. Have you seen? You are not solving, that's a problem. And we end up getting wrong answers here. Because where there's bx, I plugged in 127 instead of 127.28. What answer are you finding?
Negative 12.54.
Yes, negative 12.1454. So negative 12.54. Believe me, if you are not if you're not using your calculators there, I'll end up finding wrong answers. If this question comes tomorrow, you remember this, and then you think as if you are the one who is making mistake, but it's us who has made a mistake here. That's why I'm telling you to say you should also be solving there. Okay, so let's go to Ry, ay, by, cy, dy. 0. Ay is 127.28. Cy is negative 55. dy we don't know. What of ay? Ay is 0, right?
Yes, AY is 0 because it's lying on there.
So 127 plus 2 times 0.28 minus 55. What are you getting? I'm getting 72.28.
72.28
So our dy will be,
negative 72.28.
yes. So our dy will be 72.28. Now we are trying to find dy or d. So you say the d, you put an arrow, meaning the resultant is dx squared plus dy squared. So our d is negative 12.54 squared plus 72.28 squared. You can ignore the negative inside there when plugging in using your calculator, because if you square that one will be positive 0.45. I square it plus 72.28 squared. I'm getting 73. Can you confirm?
Yes, it's correct.
Now, after finding this, you need to find the angle. It's always like that. Find the resultant. Yes.
I don't know why I'm not getting a negative on the 12.5.
No, you are getting,
I'm
no,
not
you are getting 12.54 also.
Yes.
Kairi.
Negative.
Yes, Kairi. So it's like this. We have 0 is equal to 12.54 plus dx. We are shifting this to the other side. That's why it's negative 12.45.
Oh, okay. Thank you.
Okay. So we have found that. Now let's go ahead and find. Can you mute your mic? Mute your mic. Let's find the angle. Now the angle, you need to be careful. The x component is negative, the y component is positive. We expect our angle to be in which quadrant? X negative, y positive. The third. X negative, y positive. X negative, y positive.
I think I
Second.
think
Both
Y is also
negative.
positive. 2.28.
Sorry.
They are both negative.
They're both
They're both negative.
they're both negatives.
Yes.
Okay, then it's supposed to be in the third quadrant. In the third quadrant, when you find the angle, you add 180. If the angle falls in the second quadrant, you just follow this. If x is negative, y is positive, then it's in this quadrant. If both are positive, it's in this quadrant. If x is positive, y is negative, it's in this quadrant. When the angle falls in the first quadrant, you get the angle the way it is. After using this formula, r dy over dx, you find the theta. That will be the answer if the angle falls in the first quadrant. If the angle falls in the second quadrant, the answer you're going to find here, you say 180 minus the theta. If the angle falls in the third quadrant, you say 180 plus the theta. If the angle falls in the fourth quadrant, you say 360 minus the theta. That is important. Okay. So, in this case, it falls in the third quadrant. I'll say theta will be equal to tan inverse dy over dx. When plugging in the values here, ignore the negatives. Don't plug in negatively, just ignore them. It's okay. 72.28 divided by 12.54. So theta will be equal to, shift turn, open brackets, 72.28 divided by 12.54. I'm getting 80, confirm, 80.32 degrees. Can you confirm?
80.15.
Yes, which is 80.2. So now, since it falls in the third quadrant, we add 180. So you say 180 plus 180 plus 80.2. So the angle in the third quadrant is 260.2 degrees. That's the answer. Unless you have questions now there. It's okay? Let's do the last one for the day. Zambian footballer Collins Kango kicks a football vertically upward in a celebration after scoring a Serbian Cup winning penalty with a speed of 35 meters per second. What time does it take for the football to reach the maximum height? This is free for now. You kick the ball vertically upward. It goes there. Are you getting me? So we expect to Are you guys getting me?
Yes.
So when you reaches at the maximum height, the final velocity is 0. But the velocity which he was using when kicking the ball is the initial velocity, which is 35. We want to find the time. Which formula can we use? We don't have D. V final is equal to the V initial plus GT. This formula doesn't have H, or doesn't have the distance, so I can use this. The final is 0, the initial is 35. It was going up against the gravity. G is negative 9.8 times T. Shift 35 to the other side. Negative 35 is equal to negative 9.8 T. Divided by negative 9.8, negative 9.8, T will be equal to negative will cancel, 3.68 or 3.7. Six marks. Now, how do you get these 6 marks? 6 marks, you get it from you coming up with this free body diagram, the way I've come up with here, plus this. Don't just go direct. Come up with a free body diagram. Free body diagram, it also adds marks. Understand the question. Come up with a free body diagram. Any free body diagram. So like in this case, the best free body diagram I can show you is this. This is the ground. So you say this is the ball. It goes there. It reaches here. You say the final velocity, 35 meters per second. You say that distance is the maximum, H max. The final velocity is 0. This is the best free body diagram.
So I have a question.
Yes, please.
So, like the one you told us on the elevators, so it's only on the elevators where if you're coming down, the
No.
direction is negative.
Oh, yes. It's because we're talking about the linear acceleration in that case. We're not talking about the acceleration due to gravity. But the acceleration due to gravity, when you are going up, is negative. When it's coming down, it's positive. But now when it comes for elevators, we're talking about Jesus Christ. Elevators, when you are going up, the acceleration is positive. When coming down, the acceleration is negative. Elevators, we're talking about the real acceleration, the ring acceleration, not acceleration due to gravity. Acceleration due to gravity is g. Now when it comes for g, when an object is going up, it's negative. When it's coming down, it's positive.
Okay, thank you. I've understood.
So for today we end there. I'm tired.